Hello everyone, I hope this webinar finds you well. I see some people are in the process of joining us. Let's give them a little more time. Welcome to Frontline Systems webinar on Analytic Solver Comprehensive, your decision intelligence companion. My name is Dr. Sima Maliki and it brings me great pleasure to serve as your host. Thank you for joining us. Our plan is to cover a wide range of topics. Due to our time limit, I encourage you to send any questions you may have to consulting@solver.com. This will ensure we can address them thoroughly. For many decades, industries and organizations across the globe have been leveraging Frontline Systems products for optimization, Monte Carlo simulation, and data science, yielding significant benefits. Today, we are excited to explore the powerful capabilities of Analytic Solver Comprehensive, our all-in-one software solution that integrates these three essential functionalities. Analytic Solver Comprehensive offers numerous advantages: streamlining workflows, maintaining data consistency, and enhancing collaboration, and many other capabilities ensure your efforts add maximum value and are effectively utilized in your decision-making process. To illustrate these benefits, we will dive into a practical example from the mining industry. We will start with a deterministic linear model to optimize the extraction, selling, and purchasing decisions for iron ore, copper, and coal. This will help us maximize profits and set a solid foundation for our resource allocation strategy. Next, we'll introduce uncertainty into the model using Monte Carlo simulation. This will demonstrate how the software can simulate various scenarios and account for potential variability in demand and market conditions, enhancing our decision-making under uncertainty. Finally, we will delve into data mining and predictive analytics. By applying these techniques to historical data, we can uncover valuable insights and forecast future trends. Specifically, we will focus on predictive maintenance to ensure that our equipment operates efficiently and to prevent failures that could hinder our extraction goals. This example highlights the seamless integration of Analytic Solver capabilities, showcasing its effectiveness in enhancing decision-making and operational efficiency within an industrial setting. Why choose an all-in-one solution like Analytic Solver Comprehensive versus individual Analytic Solver products or competitive tools such as At-Risk? Analytic Solver provides a seamless workflow, eliminating the need for you to switch between different software tools. This integration enhances productivity by allowing you to perform all necessary analysis within a single platform, reducing the time and effort required to transfer data between different tools. Moreover, you only need to learn one interface, which accelerates the learning process and increases proficiency. This can lead to faster implementation of results and quicker decision-making. In an industrial setting, training staff on a single tool means faster learning curve and easier proficiency. Team members can start contributing valuable insights rather than spending expensive time learning multiple tools. Furthermore, having all functionalities in one software ensures data consistency and integrity. I will show you today how easy it is to seamlessly share results in Microsoft Teams. This ensures that the most up-to-date information is accessible without the need for cumbersome email exchanges. More importantly, It facilitates better collaboration among team members. Furthermore, you can easily create custom visuals and harness the analytical capabilities of Power BI and Tableau. Analytic Solver goes beyond traditional software such as at-risk by allowing the creation of cloud services from models created in Excel, enabling easy development of mobile and web applications. This feature ensures that results can be shared with anyone, anywhere, and anytime, facilitating widespread accessibility and collaboration. Using a single comprehensive software versus multiple tools reduces licensing fees, training costs, and the need for IT support for maintenance. You can easily scale up your models, accommodate growing data, and meet your evolving analytical needs. Let's have a quick overview of Analytic Solver optimization, simulation, and data science features, and then navigate through the ribbon. Here is a highlighted list of Analytic Solver's powerful optimization capabilities. You can solve large-scale optimization models in Excel. You're fully equipped with deterministic and stochastic optimization capabilities. You can run multiple parameterized optimizations. You have access to dimensional modeling, and you can deploy your models, and much more. These are just some of the empowering features of Analytic Solver when it comes to optimization. This is a highlighted list of Analytic Solver powerful Monte Carlo simulation capabilities. It allows you to quantify, control, and mitigate costly risks. You can easily define distributions and calculate statistics, create different charts, use decision trees, and use simulation optimization. Dimensional modeling and model deployment are also available. Furthermore, with one click, you can convert an at-risk model to Analytic Solver and access all these possibilities. Here is a list of Analytic Solver data science capabilities: forecasting, machine learning, text mining, partitioning, transforming data, extracting features, synthetic data generation, finding the best model for you, and automated risk analysis of machine learning models. You can create multi-step data science workflows and do much more. Here are other empowering features of Analytic Solver. It offers single-stage and multi-stage decision trees and decision tables in full compliance with DMN rules. Analytic Solver offers you deployment capabilities. You can effortlessly deploy your models to the cloud, create custom applications, and explore new possibilities. Your results can be shared dynamically in Teams, Power BI, Tableau, and made available to other people through Rayson Decision Services, another full-line solvers platform. Moreover, Analytic Solver allows using Excel for other tasks while the optimization runs outside Excel. And you have 3 different choices to run your model outside Excel. Now let's walk through the ribbon. Here is the Analytic Solver ribbon for optimization and simulation, and here is the data science ribbon. Let's start with Analytic Solver ribbon. I'm going to start from the left side. Let's click on Model drop-down. Multidimensional modeling for optimization and simulation is available here. This tool is very helpful when building larger models where there are multiple products, projects, or investments or time periods. Dimensional modeling can turn a very complex, hard to maintain spreadsheet problem into a simple, well-structured, easily maintained, and expandable model. It works great with pivot tables. Optimization Group offers you all you need to set up your optimization models. You can solve large-scale optimization problems with or without uncertainty. Analytic Solver offers a state-of-the-art technology on stochastic programming and robust optimization methods. In addition, it has the fastest performance in simulation optimization, many times faster than its competing products. Simulation Model tab allows you to set up simulation models. Here you can click the distribution button to access a range of predefined probability distributions. You can select an appropriate probability distribution and parameters to model the uncertainty of each input variable for your model. If you are not sure what distribution to use, you can use the distribution wizard. Do you have historical data? Let's say no. Click on next. Now it gives you a lot of ideas. Let's click on next. You must choose or create your own distribution. First step is to determine whether to use a discrete or continuous form, and you can continue. It gives you guidance on each step till you find the appropriate distribution. Let's go back to distributions. Here is the convert button. This is the one-step option for you if you have an at-risk model to convert it to an analytic solver model. You have access to meta-log distributions that can closely approximate virtually any classical continuous distributions and often can better fit user data than classical distributions. Here is the decision model group with access to decision trees, decision tables, and box function. Next is Parameters tab. It provides the options to run multiple parameterized simulations or optimizations. In the Solve Action group, you can run your simulation, access interactive simulation, basically play what if with your simulation model live. And then you can click on optimization to solve your optimization problem. And you can solve your model in different formats. You can actually analyze the model, analyze the transform model, and solve without integer constraints, solve for recurse variables, or run on a solver server. This choice allows you to solve your model outside of Excel. You have three alternative options. Go to Options tab, go to General, and click on Add Server. Here you can see you have three options. On our public Azure-based Raison server, our containerized Raison server, which actually brings all the capabilities of Raison to your own PC, another physical or virtual PC on your LAN, or your own cloud account. And the third option is Solver SDK product. This allows for concurrent Excel use. You can actually use Excel for something else, typically working on a different workbook, while your long-running model is solved outside Excel. And once the final solution is available, you can get a notification in Excel if you want, and your workbook containing the original model will be automatically updated without disturbing anything else you are doing. We will get back to deploy options. Here on the Analysis tab, you can analyze the results, create reports and charts. Various reports are available for optimization and simulation. Under Tools tab, you can fit an analytical distribution to your historical data. Let's click on Deploy. Here you can turn your model into an Azure-based cloud service, usable by any application that consumes JSON or OData. This is just with point and click and no coding required. You can use Teams, share results, use cloud services, work with Power BI, Tableau, Power Apps, Power Automate, Solver SDK, and create web or mobile applications. Get Data allows you to draw a random sample of data or summarize data from various sources, another Excel worksheet, Power Pivot, an external SQL database such as Oracle DB2 SQL Server, or a dataset with up to millions or billions of rows stored across many hard disks in an external big data compute cluster running Apache Spark using our big data. Check your license status. And let's click on AI agent. Analytic Solver offers an AI technical support agent. Let me just log in quickly. This AI technical support agent is based on the same technology as ChatGPT, and it has studied thousands of pages of online help and user guides. Everything about optimization, Monte Carlo simulation, and data science is available for you to utilize. Let's click on help. Here you can access user guides, Analytic Solver user guide, reference guides, and data science user guide and reference guide. Example models are available for optimization, Monte Carlo simulation, and for stochastic optimization, decision tables, decision trees, and forecasting data science examples. From help, you could also access education and training, including Solver Academy with courses on optimization, simulation, and data science, video tutorials, live webinars, and much more. Let's click on Data Science tab. You have access to get data again. You can use generate data, and this tool creates synthetic data when there isn't enough original data available. Next is Explore tool. It allows you to visualize your data and provides you with options for feature selection and analyze data capabilities. Transform tool offers a complete set of data handling utilities to clean your data, including missing data handling, transforming continuous data, and transforming categorical data. You have access to clustering or data segmentation. Here's the text mining available in Analytic Solver Data Science, allowing you to gain insights from your unstructured text data. You have access to built-in time series analysis tools, including partitioning, ARIMA, and smoothing techniques. Here is the data science group, including partitioning, to partition your data to training, validation, or test sets using standard partition or partition with oversampling. So a model can be trained and then evaluated. You have access to supervised learning algorithms, 10 supervised learning techniques, including 6 classification and 4 prediction methods. You have also access to ensemble methods and finding the best model option. Analytic Solver will automatically test and fit parameters for multiple types of machine learning models. It validates and compares them and delivers the model that best fits your data. Furthermore, risk analysis of machine learning model is available on the fly within each algorithm. You have access to association rules. You can score your new data, check your license status, access AI agent, and help. Now we delve into our application in the mining industry. We'll begin with a deterministic scenario to optimize the use of our resources and make the best possible decisions. Following that, we will explore how incorporating uncertainty and leveraging both the optimization and simulation capabilities of Analytic Solver can enhance our decision-making process, leading to more accurate and effective outcomes. Let's start with the deterministic scenario. This worksheet contains a linear model that determines how much a mining company should extract, sell, or purchase to maximize profit. This model does not include any uncertainty yet. This mining company has a mining area of 500 hectares available to extract either iron ore, copper, or coal to sell for a profit. Here is the selling price for iron ore, copper, and we have 2 prices for coal. Due to mining regulation, there are some minimum requirements. We need at least 200 tons of iron ore and 240 tons of copper to support other operations. And these can be either extracted or bought from the market, and the purchase price and extraction costs are presented in these 2 rows. The company must decide on the amount of each resource to extract, sell, or purchase before the amount of demand in the season is known. The amount of demand is uncertain, but we are not incorporating this uncertainty in this version of the model. And here are the average yields of these three resources: iron ore, copper, and coal. Let's talk about variables. The variables in cells D27, E27, and F27 are the amount of hectares to devote to iron ore, copper, and coal. Variables in D30 through I30 are amount of iron ore, copper, and coal to purchase and sell. All decisions must be made here and now. In a few minutes, we will review the stochastic model to see how we can take a wait-and-see approach to decision making. All variables must be non-negative. In addition, the number of coal sold has been split into two variables: less than 6,000 tons and greater than 6,000 tons. As a result, F30 must have an upper bound of 6,000. Any amount sold over 6,000 tons will be added to the variable in G30. There are 4 constraints in this model. We are going to ensure that the land used for extraction does not exceed the 500 hectares, the total lands available. We have variables ensuring that at least 200 tons of iron ore are available for operations, and 240 tons of copper are available for operations after a portion has been sold. And we want to make sure with G33 greater than 0 that amount of coal sold does not exceed the amount of coal purchased and extracted. The objective function in cell D39 is maximizing total profit. You can always verify all the components of your optimization model under Model tab of task pane. So we have the objective, variables, constraints, and variable bounds. Next, let's click on Optimize to solve this model. This time we are going to use guided mode. This is a step-by-step help providing information about the model. Let's click on Continue. This model is diagnosed as LP or Linear Programming Convex. Click on Next Step and we get the result message that Solver found an optimal solution for us. Here are the results, and on the task pane, Output tab, you can view a log of optimization message. There are other tabs in the task pane. We talked about Model tab. Platform tab gives you options such as number of optimizations run and much more. You also have Engine tab. Here there are solver engines to solve your model according to your structure. For example, this was an LP model, linear programming model, so you could use standard LP quadratic engine to solve this model. So you have built-in engines, standard GRG, LP quadratic, evolutionary engine, and standard interval global engine, and SOCP barrier engine. You also have access to additional add-in engines. For example, Groby solver engine, Nitro, large scale of GRG, LP, and SQP engines, and much more, including OptQuest and Mosaic and Express. Now that we have used Analytic Solver to create and solve an optimization model and get results, let's take the next step and find out how to share our model and its results with other users in a repeatable and manageable process. With Analytic Solver, you can deploy your model with ease, share results seamlessly in Microsoft Teams, create custom visuals to enhance understanding, and harness the analytical capabilities of Power BI for advanced insights. These features allow access to most up-to-date information without needing to email cumbersome workbooks back and forth, and fully equip you to move beyond traditional PowerPoint presentations by sharing dynamic, interactive results in Teams and Power BI. But that is not all. Analytic Solver goes above and beyond by also working with Tableau and enabling the creation of cloud services from models created in Excel, allowing for easy deployment of mobile and web apps and sharing results with anyone, anywhere, and anytime. You can achieve this by using a cloud service which is made available to you by Frontline System and is called Raison Decision Services. Next, we're going to talk about Teams integration. Microsoft Teams is one of the most popular collaboration platforms. Analytic Solver integrates with Microsoft Teams and allows you to share your optimization and simulation model results within your existing Teams channels and conversations private to your organization. This eliminates the need for manual data transfer or external file sharing methods. Furthermore, Analytic Solver Teams integration ensures that optimization and simulation model results are always up to date within Microsoft Teams, providing you with real-time access to the latest insights, recommendations, and decision support information. Let's get started. If you want to share your interactive model results without sending the whole workbook, you can send a report through Microsoft Teams containing interactive links to your original workbook. I will walk you through the steps. Step 1. Your workbook must be saved to a location that is network accessible, such as OneDrive or SharePoint. Step 2. You must first solve the model and save the workbook. Otherwise, Teams won't be accessible. After clicking on Teams, you can click on Teams Report. In this dialog, you can decide which model components to include in the report. I'm going to click on this button to include everything, all the variables, functions, and objective, and click on OK. Next, you will see a message Teams dialog. Here you can select the team and channel where you would like to share the results. Let me change this to test team, general. You can change your workbook name. You can also type in an optional message. I would say, hi, please review the latest results. You have report options to include, and click on send, and within a few seconds you will see a message appear that file was successfully sent to Teams. You can solve or simulate again to refresh the Teams workbook. Let's click OK. Let's open Teams and go to the proper channel. I put it in test team in the general, and here it is. It says, hi, please review the latest results. I can click on this report, click on trust workbook links, and here are the results. As you can see, the new workbook is saved online. It is available to users you want through a team channel that you select. Your colleagues can now see your model results in Microsoft Teams. Furthermore, you can open Teams report using Teams itself, or you can open in Excel desktop or your browser. If a parameter changes on the original model worksheet, simply resolve the optimization model and then click the refresh icon. There is no need to deploy a new Teams report. This is just an example of what can be done. You are invited to customize this report in a design of your choice. This example demonstrates the enhanced collaboration capabilities available within Analytic Solver. The results are shared dynamically in Teams, enhancing real-time collaboration. This is just one method. With the deployment options, you can go beyond Excel and explore further possibilities. If you are unsure which deployment option to choose, the deployment wizard can guide you through the available menu options. Click on next. The wizard will help you choose the best option. And for additional support, you can refer to our YouTube channel where previous webinar recordings on these topics are available. Let's go back to our example and consider uncertainty to create a more realistic scenario. We will explore the value of Analytic Solver Monte Carlo simulation features, which are seamlessly integrated within the same software as the optimization tools. This powerful combination enhances your decision-making capabilities, making your journey toward data-driven decisions easier and more efficient. We enhance our deterministic model by incorporating historical yields of each resource and using Analytic Solver fitting tool to fit an appropriate distribution to our data. This approach allows us to account for uncertainty and create a more robust optimization model. Analytic Solver includes a powerful facility to automatically fit user data to the full range of possible bounded and unbounded multi-term meta-log distributions. Let's assume that the yields of the three resources are uncertain and are highly correlated with the amount of demand. We have historical data on the yields of iron ore, copper, and coal. Let's begin with iron ore. Here's how we can proceed. Select the first column of values and click on Tools, Fit. Here you can select your distribution type. Let's keep both. You can choose the location of your sample data. You can decide whether to use continuous or discrete. I'm going to accept the default settings. Leave the max term, the default value of 16. This is the number of terms in the meta-log function. The minimum number of terms is 2. This will allow the meta-logs of all terms up to the max term to be calculated and displayed in the results. The lower bound must be a value lower than any data point, and the upper bound must be a value greater than any data point. Let's enter 2 for the lower and 3 for the upper for iron ore. Let's click on Fit. Analytic Solver computes and displays a ranked list of candidate fitted distributions to the left. Initially, the distribution with the best fit statistic is shown in a chart that overlays the sample data. You can use the bin slider to add or subtract the number of bins in the histogram. Here on the left is a list of fit choices in the order of decreasing goodness of fit based on the test you choose. You can also choose and compare multiple choices. You can click on PP, QQ, CDF difference and CDF difference tabs to get additional perspective on which distribution best fits. Next is meta-log panel, and you can see all feasible meta-log density functions. And remember, the larger the number of terms, the greater the possibility that the distribution may overfit the data. Okay, I'm going to skip all the details. Next, let's click on Save and paste the distribution in, for example, K1. I have good news for you. You can deploy and share this fitted distribution. I'm going to skip copper and coal. I've already completed those steps, but I'm going to instead show you how you can actually deploy and share this fitted distribution. Let's click on Deploy Model, Cloud Service, Probability Model, and then you can export the distribution to your Rayzon Cloud account. This is the distribution in K1. Add it to selected distribution and click on Save. By doing this, you can see that automatically Rayzon.com, the model editor, opens up and shows you that your distribution is now exported, and you can see a copy of it on Rayzon.com. I'm going to skip the details. Again, there are recorded webinars that you can watch on our YouTube channel and learn more about all these steps. Once this distribution is exported, you have the option to import it, and your colleagues can also import it and use it. So let me show you how you can do that. Let's open a blank workbook. Let's click on distributions on Analytic Solver ribbon, and you can see the option import is available. Click on import. Here is the import dialog. Let's go to mining example and select distribution K1, and let's paste it in A1 and click on import, and here it is. Now let's go back to the stochastic model. Now let's go back to the stochastic model. How much land should the company devote to each resource? As in the deterministic model, the company must decide on the amount of each resource to extract before the amount of demand in the season is known. However, in this model, the decisions on the sale and purchase of each resource can be decided once the yields of the 3 resources are known. Here in this example, the uncertainty will be resolved over the horizon of interest when we know the amount of demand. So we can have a 2-stage approach, where the normal decisions are made at the first stage before the uncertainties are resolved, and the recourse decisions are made at the second stage after they are resolved. As you may recall, the yields of the 3 resources are uncertain and are highly correlated with the amount of demand. I have used the metal-log distribution that fitted to historical data for the yield of iron ore. And we have used uniform distributions for copper and coal to represent the uncertain variables. We have 2 groups of decision variables: normal decisions on the extractions and recourse decisions on the sales and purchases to decide later. The company must decide on the amount of each resource to extract before the amount of demand in the season is known. After the demand is known, the yields of the 3 resources are known, and then the company can make final decisions on the sales and purchases of each resource. We will use recourse for cell D32 through I32, which are the amounts of iron ore, copper and coal to purchase and sell. They are defined as recourse variables. To define variables as recourse, go to decision. You have 2 options, normal or recourse, for your decision variables. Let's talk about the objective function. As you can see, it is defined as expected total profit. We must maximize the expected total profit. Since we have 1,000 different objective function values, one for each of 1,000 trials, the solver requires the objective to be generalized into one function. An easy way to do this is by taking the mean or expected value of objective function. Now we are ready. Let's click on Optimize. Let's walk through the guided mode. As you can see, Analytic Solver was able to automatically transform our model with uncertainty into its stochastic programming deterministic equivalent. Let's click on Next Step, and here are the optimal results. Normal variables have optimized values. However, as you can see, a single recourse variable represents an array of solution values, one for each realization of uncertainties in the model. Yields of iron ore, copper, and coal are uncertain, and we model them using analytical distributions. The default simulation trial value was 1,000, therefore you can think of the uncertainties as 1,000 different values. Then when time passes, say 6 months later, and the uncertainty has become known, the amount of demand and hence the total yields for resources are known. Then you or the company can replace the uncertain variables with those known numbers and then do a simple solve. Solve for recourse variable that's available in the software. Under Optimize, solve for recourse variables. So let's quickly show you how to do this. We assume that it is 6 months later, the company extracted its resources, they have been processed, and it measures the yield for all three resources. It is time to replace these distributions with the three actual measured yields. Then we have to optimize one more time. And remember, we are not going to change stage 1 variables because those were dealt with 6 months ago and we don't have any uncertainty anymore. We just have the recursive variables left, which now become regular decision variables. But for your convenience, you don't have to fix stage 1. You just click on solve for recursive variables. The yields are replaced with constant values. Now we can go ahead to click on optimize, solve for recursive variables, and here are the final results. This was just an introduction to stochastic optimization made possible by Analytic Solver's advanced optimization and Monte Carlo simulation capabilities. There is much more you can achieve using the full power of Analytic Solver. If you are interested in learning more, we invite you to explore a previous webinar recording that includes detailed examples and insights from the oil and gas industry. If you are interested in learning more, we invite you to explore a previous webinar recording that includes detailed examples and insights from the oil and gas industry. Here is the Analytic Solver's YouTube channel. Go to educational webinars and you can find previous recordings. I have shown you how Analytic Solver can handle both optimization and simulation, showcasing its comprehensive capabilities. You might be thinking, I don't need data science capabilities. However, consider this. Your business, other departments, or even your colleagues may have data that could benefit from your expertise. By exploring the data science tools available in Analytic Solver, you can uncover valuable insights and enhance decision-making across your organization. Take a closer look and you might discover opportunities where data science can truly make a difference. Let's find out how we can use data science within the mining application. In the mining industry, equipment failures can lead to significant downtime and loss of productivity. Predictive maintenance helps anticipate these failures and schedule timely maintenance, ensuring smooth operations and achieving extraction targets. This dataset contains historical data on equipment usage, maintenance, and performance, which can be used to analyze equipment performance and predict failures. This supports maintenance optimization and operational efficiency. This dataset includes 300 rows and various variables such as equipment type, usage hour, age, maintenance cost, failure count, operating temperature, soil condition, and production output. The target variable is equipment failure, indicating whether an equipment failure occurred or not. When the failure occurred, it takes the value 1, otherwise 0. As part of your preliminary analysis, you can use feature selection techniques to identify the most significant variables influencing equipment failures. This approach reduces the dataset's dimensionality and enhances the accuracy of predictive models. Let's explore the value of feature selection using our dataset. Although our current dataset has only a few variables, a more comprehensive dataset would have many more. Utilizing feature selection techniques allows us to efficiently identify the most predictive variables related to our target outcome. We aim to find out which attributes have the most predictive power for equipment failure. Let's find out how. Select a cell within the data. Go to Data Science ribbon, click on Explore, Feature Selection. Select your continuous and categorical variables. Equipment time and soil conditions are categorical. I'm going to skip equipment ID, and your output variable is equipment failure. Confirm that categorical is selected for your output variable type. We have individual webinars focused on data science, optimization, or simulation. If you're interested to learn specifically about data science, you can join one of our weekly data science webinars. Let's click on Next. This is the Measures dialog. Since we have continuous variables, discretized predictor is enabled. When this option is selected, Analytic Solver Data Science will transform continuous variables into discrete categorical data to be able to calculate statistics. Select chi-square and Kramer's V, mutual information and gain ratio. Click on Next. Under Feature Selection, select Feature Importance Plot. This option produces a report containing the top variables as indicated by number of features edit box. I'm going to increment the number to include all of our features. And we will get a graphical representation of variables importance based on the measure selected in this rank by drop-down menu. Let's keep the chi-square test. Let's click on Finish. Here are the results. Let's go to top features. Here is the feature importance plot ranking the variables by the most important or relevant according to the selected measure. Maintenance cost, usage hours, age are the top 3 most important variables. High chi-squared value indicates a strong association with equipment failure. This chart helps us quickly identify the largest drops or elbows in the feature relevancy or importance and select the optimal number of variables for a given classification or regression model. Let me close this. Here is the feature selection detailed output report, displaying each computed metric selected on Measures tab. For example, let's look at mutual information. We can sort this column by largest to smallest. The closer the one, the more contribution the feature provides. As you can see, let me expand this column. Maintenance cost, usage hours, and age are again the top most relevant variables. You can look at other features and decide very quickly which variables are the most relevant and which ones are not. And use the most relevant features in your predictive modeling process to build an accurate and efficient model for preventive maintenance and resource planning. This tool allowed us to quickly explore and learn about our data. These features can be used in the predictive modeling process to build an accurate and efficient model for preventive maintenance and resource planning. Now that we understand our data better, how can we determine if a new piece of equipment is at risk of failure? Can we build a predictive model to forecast equipment failures by fitting a supervised model to our data and then scoring the new data using the fitted model? Yes. Our goal is to fit the best model to the dataset and then use this fitted model to determine if a new equipment is at risk of failure. Instead of trying multiple algorithms, you can take advantage of the Find Best Model option that automates this process for you. This tool fits a model to all selected supervised learning methods in order to observe which method provides the best fit to the data. Certainly, you can test each supervised method individually. However, Analytic Solver can significantly streamline your workflow by automatically identifying the best model, potentially saving you hours of effort. Let's go back to our data. Select a cell within the data, go to Classify. Let's click on Find Best Model. Here is the first dialog. Output variable is equipment failure. Equipment type is categorical as well as soil condition. All remaining variables are continuous. Click on Next. This is parameters dialog. You can click on pre-processing to partition your data to training and validation sets. I'm going to accept the default settings. Here you can choose the learners. You have option to adjust parameters for the learners. I'm going to skip the details. Feel free to refer to our user guide or join one of our webinars. Find Best Model scoring determines how well each classification method fits the data. Here you can choose your metric for scoring. Let's click on Next. Let's choose Detailed Report and click on Finish to get the results. CFPM output contains a listing of all model inputs such as input-output variables and parameter settings for all learners, as well as model performance tables containing evaluations for every available metric, every learner on all available partitions. CFPM stored contains the PML or the predictive model markup language model, which can be utilized to score your new data. Selecting a detailed report option produces these two worksheets: CFPM training score and CFPM validation score. Both reports contain detailed scoring information on both the training and validation partitions using the best learner. Misclassified records are highlighted in red. The best performing method according to training data and measure selected is decision tree. The Find Best Model tool made it quick and straightforward to identify the most effective supervised learning algorithm. Here, decision tree for predicting equipment failure. This ease and speed in finding the best model significantly improves maintenance scheduling and operational efficiency. The ability to seamlessly combine optimization, simulation, and data science in one platform demonstrates how an all-in-one software solution can be effectively used in the mining industry to enhance decision-making and resource planning. This integration provides a powerful, efficient, and user-friendly tool that can transform the way businesses operate, ensuring they are well equipped to tackle complex challenges and achieve their goals. In this webinar, we demonstrated these capabilities using an example from the mining industry. However, the power and versatility of Analytic Solver extend far beyond mining. This tool can be applied effectively in various other industries such as healthcare, predict patient outcomes, optimize resource allocation, and improve operational efficiencies in hospitals. In finance, forecast market trends, manage risk, and optimize investment portfolios, for example. In pharmaceutical industries, streamline drug development processes, optimize clinical trials, and improve supply chain management. And in manufacturing, for example, enhance production scheduling, predict machine maintenance needs, and optimize inventory management. The ability to seamlessly utilize powerful optimization, simulation, and data science capabilities in one platform can enhance decision-making and resource planning across various sectors. This integration offers an efficient, robust, and user-friendly tool that can transform business operations. Furthermore, your models can be easily deployed to the cloud, your results shared in Microsoft Teams, and visualized in Power BI and Tableau, allowing real-time collaborations. Moreover, Analytic Solver allows using Excel for other tasks while the optimization runs outside Excel. By using Analytic Solver, you are well equipped to tackle complex challenges, make informed decisions, and achieve strategic goals. Whether you are in healthcare, finance, pharmaceuticals, manufacturing, or any other industry, the comprehensive capabilities of this all-in-one solution can drive significant improvements in efficiency and effectiveness. This was just an introductory webinar. To learn more, you have access to free webinars, tutorials, and user guides to maximize the utility of the tool. Let me show you how. Go to solver.com. Under resources, you can access case studies, training webinars, Solver tutorials, Excel examples, and many demo videos. Thank you for joining today's webinar. We hope you now have a clearer understanding of how Analytic Solver can be leveraged in your industry to optimize operations and make better decisions. If you have any further questions or need more information, please feel free to reach out. Here is my contact information along with that of our other team members. You are welcome to contact us with any questions or comments. Again, to explore more features of Analytic Solver, we invite you to join our specialized webinars focusing on optimization, simulation, and data science. We appreciate your time and interest and look forward to hearing from you soon. Thank you again, and goodbye for now.